Welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about double tuned amplifiers. So let's see the need for double tuned amplifiers. So we have already discussed about the tuned amplifiers. So here we need to improve the selectivity of your amplifier and also adjacent channel rejection. So this can be achieved by using a double tuned amplifier, and also it improves the signal to noise ratio of the amplifier circuit, and it provides the better selectivity by using the higher quality factor and gain optimization. So here we have a two tuner circuits in the amplifier. What is the definition of double tune amplifier? Here it consists of two tuned circuits L1C1 and L2C2 as shown in this diagram. So this double tuned circuit is connected at the collector section of the amplifier. So here we can see the circuit diagram for double tuned amplifiers. So here the common emitter configuration amplifier is used, and at the collector we have two tuned circuits L1C1 and L2C2. Collector of the amplifier is connected to L1C1, and it is connected to the second using mutual coupling method. So this double tuner amplifier is used to provide the better selectivity. And what is working of double tune amplifier? So the input signal is given to the amplifier circuit and tuner circuit L1C1. So first circuit is tuned to the given input signal frequency. So this circuit offers the high reactance to the input signal, and double tuned circuits are used for coupling the various radio and television receivers. So here we can by adjusting the coupling between the two coils L1 and L2, we can get the high selectivity and high voltage gain and the required bandwidth. So this provides the high selectivity, and also the required bandwidth can be achieved. And here the mutual inductance concept is used in the tuner circuits. So where primary coil is given with the input signal. So when the EMF is induced in the secondary coil due to the time varying magnetic field from the primary coil. So this phenomenon is known as the mutual inductance. So this is used for coupling the double tuned circuit. And frequency response of the double tuned circuit. So here two positions of gain maxima, and one above and the other below the resonant frequency. So as shown in this diagram, the gain versus frequency graph is plotted. So at the resonant frequency we have two positions of gain maximum. So one is for loose coupling and another one is for tight coupling. This depends on the distance between the two coupling circuits. So by next, bandwidth of the double tuned circuit. So here the bandwidth depends on the two factors. One is quality factor and coupling. So the determining factor is the coupling factor, which is coefficient of coupling K, and Fr is the resonant frequency. So bandwidth increases with the degree of coupling between the two tuned circuits. And let's see the advantages of double tuned amplifiers. So it provides wider bandwidth and also high gain. So it provides increased amplification at the resonant frequency and impedance matching and stability in radio frequency application. So it reduces distortion in this RF circuits. So it also provides the better power transfer through the load. So it provides good impedance matching also, and for it provides a wider frequency range and also better selectivity. So these are the advantages of double tuned amplifiers. And the applications of tuned amplifiers are intermediate frequency and TV receiver circuits and radio frequency amplifiers. So these are the various applications. And let's see the assessment questions. What is the typical frequency response of double tuned amplifier due to coupling between two LC circuits? So the answer is double humped and flattened response with sharp edges. In double tuned amplifier, the coupling coefficient primarily influences the shape and bandwidth of the frequency response. So thank you for listening this lecture on double tuned amplifiers.